Kia ora team, I hope you're all doing okay. Yeah, there we go. Kia ora team, I hope you're all doing okay. Hopefully you can see me and the sound is coming through all good. Our plan for today is to go through some stuff on electromagnetism and electric motors, which is the content for this week. Hopefully we're going to cover these ideas so they're a little bit clearer for you. So by all means, fire away any questions in the chat. And if you join a little bit later, just sign off with a little kia ora so I know that you're here watching with us live. If you have any questions as we go, feel free to put them in the chat and I'll flick over there from time to time and I can do my best to answer anything that I do a poor job of explaining. And if there's anything else you're not sure about or you watch this at a later stage, just save your questions for our Google Meet, which we will have on Friday. Good to see those of you here today, which is lovely. Why don't we make a start? Now, the first thing I'm going to tell you about is our plan for the next couple of weeks. So we'll have to see how things go moving forward regarding lockdowns and things, but we're making the assumption that we're going to be here for the next 2 weeks after this, and so we've got to have plans in place for you, and it's good of us, I guess, to make sure that you know what to expect moving forward. So next week will be the end of our topic learning. We'll have a couple of periods where we just do revision, and I'll try and make sure that there's some way for you to review the content that we've learned so far this term. We're then going to have a little bit of an Education Perfect test. Now, this is just a test on your current understanding. Don't worry, you have another opportunity to do this assessment when you do the end of year exams in term 4. And we know that lockdown's pretty hard, but just we want to do your best. It'll also give me a sense of what we need to work on when we go back into class sometime later on. The way that test is going to be assessed is it'll be around 50 or so multi-choice questions taken from an Education Perfect style set. The highest grade you'll be able to get is a merit because really to get those excellence marks we need to be showing linking, and it's hard to do that with an MCQ, so don't stress too much. It's just more of an indication of where your understanding is. We'll start that test and make it available from Wednesday, so you could do it on Wednesday and get it out of the way, or alternatively you could leave it to later in the week if you wanted some more time to revise. Depends on what sort of style you like. Don't stress too much about it though, because we will come back to those ideas later on. Now in week 10 we're going to do an IV, an investigation, and that's going to look at those skills that we learned about earlier in the year around doing a scientific investigation. Now, obviously, that's going to be a bit of a challenge if we're doing that online. So we're in the process of making sure that we have a good plan that supports you guys and doesn't overwhelm you with too much work. And we'll give you the details of that probably sometime late next week or at the start of week 10. Don't worry, it'll be something interesting to get you thinking about science or thinking in a sciencey way. All right. So our Te Rautaki I Te Wiki is looking at magnetism. Now, magnetism is really interesting, so we're going to have a whole lesson dedicated to that. We're then going to have a lesson looking at methods of using electromagnetism, which is magnets induced by electric currents, and one application of this, which I think called a solenoid, which we'll talk to you about later. And then we're going to talk to you about electromagnetic motors and give you an opportunity to be able to build one of these at home, should you have the tools. Our final lesson we'll be doing during our Google Meet, so I'll save you the trouble of going through that one. All right, let's start with lesson 1 on magnetism. So the first thing here is to have a bit of a think. What are some everyday uses of magnets? So have a little bit of a think. If you're watching this video, either live or at a later stage, what you could do is pause, have a bit of a think, maybe write some things down, and then I can reveal the answers to you. You're welcome to pop them in the chat now if you want to, if you can think of any off the top of your head. But for those of you watching in retrospect, I'm going to give you a few seconds. You can pause the video now. 5, 4, 3, 2, 1. And some uses are as follows. So compasses. measure the Earth's magnetic fields and allow you to orientate yourselves with relation to those, understanding which way is to the magnetic North Pole and which way is to the magnetic South Pole, which is quite interesting. You might have found that some various seals on various devices use magnets to lock things in place. You might even have cupboards in your house that use these. But there's a variety of hinges that snap shut by the use of magnets. If any of you own AirPods cases, I'm pretty sure the lids click in by that, and so do the little AirPods themselves. They slot into place with the aid of magnets. Any bank cards that your folks or you might have, those work based on the use of a little magnetic strip, which is why you should never expose bank cards to any magnets, or it's going to render them ineffective. Most hard drives use magnetic use magnetism as a way to store data. And most electronic devices, including the one you're probably watching this on, use magnets to some extent, or electromagnetism in some way, in order to provide their functions. Most notably, speakers can use that. There's also a whole bunch of things you might not see in everyday life, but you will see from time to time, such as if you ever go to the hospital and you get yourself an MRI, which is based around these use of these quite powerful magnets. And so we've got some nice images that represent those. But yeah, so essentially magnetism is really important to a lot of functions, and it's important that we understand at least the basics of it, because some of you are very likely will end up at later points in your career working in this space, and there'll be some of you who'll be thinking about that. Could I work with magnets in future? And the answer is yes. So this video does a good job of sort of introducing the fundamentals of magnetism, but you've already probably had a bit of a play with magnets before. So you might know that magnets are able to exert a field of electromagnetism around them, and that they're usually made of compounds that allow for this. The most classic ones for these are iron, nickel, and cobalt, but there's a few other compounds that do this too. And there are some objects that are affected by magnetic fields and some that are not, which is interesting. And so over a long time there was a whole area of science dedicated to trying to understand why certain materials had these properties and why some didn't. A key thing to think about when we're thinking about magnetism in general is the idea of these magnetic field lines moving from one place to another. So you can imagine that when we draw or want to represent these magnetic fields, we can do this sort of like a diagram that you're seeing on the right here. So we, by convention, draw the magnetic field lines as arrows, and we draw them going from the North Pole to the South Pole. Part of the reason why we do this is because if you get two North Poles and push them together, you'll notice that they repel one another. So like poles retract, opposite poles attract, like poles repel. And the classic example of this, you get two little magnets, you push them against each other and they don't want to click, but you flip them over and they stick together. That's occurring because you're trying to push two like poles together, and like poles repel. So once we understand those kind of fundamentals, there's a couple of tasks here for you to do, investigating the basics of magnetism and magnetic fields. Now, for this one, you're going to be watching this video and doing a little diagram. Now, you can do this on paper and then upload a photo. You can also just do it with the Shapes tool at the top of your Google Slides, whichever you'd prefer to use. Hopefully, when we go back to class, we can have a bit of a play around with this and do a similar experiment to the one that's shown here. Once you finish this, your job is to go through these pages in your SciPad and to write a little bit of a summary, right? And the answers to those SciPad pages, if you're struggling or you want to check those out, are in the following slides, but I'll leave those for you to complete. And that brings us to the end of our first lesson. There is a little bit extra if you want to do an NCA style question. For some of you, I think you'd be ready for that challenge. But you've got enough information from what you've just been going through to be able to tackle this if you really want to. You see here an opportunity for you to draw Earth's magnetic field and explain the differences between the geographic North Pole and the magnetic field near the equator. And so there's an example for you to talk about those and some answers there for you. So that's the end of our first lesson. If you're watching this at a later stage, you're welcome to pause the video, complete that work, and then come back to this later. If you're watching it live, we're going to boost through onto lesson 2 on electromagnetism, which is magnetism induced by electricity, and these things called solenoids. So, given our information, what we've just done, you should be able to have a go at this question here, drawing the field lines from a simple bar magnet. Now, a bar magnet is just kind of like the classic ones with the two colours. They look exactly like that diagram just there. So we actually showed a diagram earlier of a simple bar magnet. And you had a go at this when you completed those slides earlier. There's also an extension question if you want to have a go at it, talking about where are the magnetic field lines the closest and where are they furthest apart. What does that tell you about the strength of those? So I'm going to reveal the answer to you here. There we go. So you'll notice all the arrows coming out of the North Pole heading into the South Pole. And the magnetic field lines are the closest, really close to the magnet. That's or close to the tips of those magnets. So you'll notice that that is where the magnetic field is the strongest, and that might make sense to you because if you get two north poles of the magnets and bring them close together, there's a lot of resistance. Whereas when they're quite far away, or maybe over on the side, there's less resistance. So more lines in the same place indicates a stronger magnetic field. This principle of drawing lines like this can be really useful for understanding the way that electromagnets function. So it's kind of important to have those fundamentals in place first before you move on to the next thing. So once we've done this, we can introduce the idea of electromagnets. So electromagnets are a variety of different things where you pass an electric current to create a magnetic field. Solenoids are one major class of this, and they're a really nice one for introducing this idea. Now, what solenoids are they are wires of usually copper wire wound in a coil, and what you find is that if you pass a current through this coil of wire, you induce a magnetic field, you create a magnetic field. And that magnetic field can be changed depending on some things to do with the copper wire and the current. If you increase the number of coils, you increase the strength. If you increase the amount of iron, so the thickness of that wire, that increases the strength as well. And if you turn up the current, that makes the magnetic field stronger. So there are 3 ways that you can increase the strength of a solenoid. Now what you can do here is pretty much limitless. You can use this magnet in any number of ways, but the cool thing about it is you can switch it on and off, unlike a bar magnet, which is constantly on. So you can do all sorts of funky things, particularly moving stuff with use of solenoids. So now that you've got that information, we're going to talk about some of the practical applications of this kind of electromagnet. And in the next lesson, we'll tell you how to make one of these. So, hopefully you can think of some real life examples. We've already had a bit of a go at this, but here's some more examples for you to be thinking about. You might not know this, but a lot of the parts of cars contain these electromagnets in order to function, and most notably solenoids. But we're going to talk about one example of this, and this is maglev trains. Maglev, the mag stands for magnet, and lev stands for levitation. Right? They are floating trains. Now the way that these work is really interesting, but we're going to talk about that in a second. But what I want you to have a little bit of a think about is why or how magnetic trains might float and why it might be a good idea to do this. Now you can pause the video here and have a bit of a think. If you know the answer, you can fire it out in the chat, but I'm going to reveal it in 5 seconds. So 5, 4, 3, 2, 1. There we go. Yeah. So they work by using these magnets to be able to float the train, which is quite cool. So essentially you've got opposing poles pushing the train apart, which is pretty neat. And we're going to talk about that exact mechanism shortly. What you've also got is when you've got this sort of floating effect, you have no friction. And we've talked about friction in this topic already. We've talked about forces. With no friction, you have no resistance to the increasing speed, or at least none coming from the wheels, for example, which have heaps of friction. So you can get up to these ridiculous speeds of over 300 kilometers an hour. So it's really useful if you want to go from one place to another. So given that information, we're going to talk about how these maglev trains work. So if you look at this GIF kind of shows how these mechanisms work. So you can imagine that the blue is like the South Pole and the red is like the North Pole. When you have a red over a red, they repel each other. When you have a blue over a blue, they repel each other. Now on the train itself, you keep those magnets, usually you keep those magnets either north or south. Usually you have really big, beefy, permanent magnets. And then on the track, you would flip these back and forth at particular intervals. Now what that causes is this repulsion that keeps the train at a particular distance. You also have a secondary set of magnets which allow for this kind of propulsion to speed up or slow down the train. Now the exact mechanisms, this is kind of the general idea, the exact mechanisms are different for different trains. But in principle, you're using the repulsion to both hold the train floating in the air, and then you're using a system where that kind of repulsion is used as a mechanism of thrust and then a mechanism of braking, which is pretty neat. In an emergency, I believe that they just switch those magnets off, and that's one of the ways that you brake all of a sudden. So this video does a really good job of explaining maglev trains and explaining what's good about them, but also what is not so good and maybe why we don't have them in New Zealand. So your job is to watch this video and then to just pop in your answers as you're going through. So we'll leave that for you. And the last task for this lesson is to tick one of these options. Now there's either these 2 pages of SciPad or these pages of your ESA book. You can pick either of them. Both are available online for you to look at. Now your job is to pop in a little bit of a summary of those, and the answers to that SciPad section are there for you. There's also a little extra for experts task around explaining maglev trains if that's something that you're passionate about and you want to have a go at that. So that brings us to the end of Lesson 2. Lesson 3 is a little bit different. This is on how to build a mini motor. So there will be some questions in here for you to answer, but then after that, this is more of an opportunity to look at a practical activity you could potentially do at home. So, you will recall there are 3 things that affect how powerful an electromagnet is. Hopefully you can remember them. If you can't, pause the video now, have a bit of a think, see what you can write down, and I will reveal the answer in 5, 4, 3, 2, 1. Yeah. 3 things are increasing the number of coils, increasing the amount or thickness of the wire, and increasing the current. So if you can do those 3 things, or any one of those 3 things, you increase the strength of your solenoid, of your electromagnet. So when you're doing this work today, building this motor, or if you have the means to be able to do so, these are things you should be thinking about if you're finding it's not working super well. So given that information, there's a little video here talking about the basics of electromagnets and talking about those ideas around increasing strength. So we want you to work through those and then type your answers out here. And when you've done that, you can have a go at building one of these. This is a little way for you to make your own mini motor. Now this isn't a required task, but if you have the means to be able to do this, this might be a fun little activity for you to do. So for this task, you'll need some various materials. Now this is explained in this video here, but I'll go through it here with you. You need some wire. You need something to wrap that wire around. You need yourself a little battery. You need yourself some sort of sharp edge for taking the insulation off the wire. You might want to do this with your parents' help. There's a variety of different things you could use for these, but the easiest ones to do would be to use something long and metallic, like an iron nail or a couple of large sewing needles, a strong magnet, which you will need to be able to do this, and some blue tack or putty or something like that. So the steps are as follows. You wrap the wire around the cylinder. Now what we know is that the more you wrap the wire around the cylinder, the stronger your magnet will be. So if you find on your first attempt that it hasn't been successful, you might try again by wrapping the wire around more times. What you should end up with is something that looks like this. And what you can do is with those loose ends of wire, wrap them round, and that will hold the coil in place. And when you've done that, you should have kind of two ends sticking out and a beautiful little coil like this. Now with parental supervision, you can take the insulation off the end of one side of each end. Notice it says one side. You can use the black marker to help with this, because particularly if the insulation, like on this one, is the same color, it can be hard to tell if you've actually managed to scrape it off successfully. But notice we said one side, right? Now, here's the setup. You've got some power here being provided by your battery. So once the battery is positioned in the right place, you can either put your sewing needles there or place these bent paper clips, which will do the same thing. Here, the nice thing about the sewing needles is that they've got an inbuilt hole in them already for you to hold your motor in. You can also do it with paper clips, but it's a little bit more tricky to set them up. So once you've done this, you can place your piece of coil in between the two, and once you've done that, you should be able to give your coil a spin and hold your magnet nearby in order to induce the spin. Now what's actually going on here is as this copper is turning, you're passing the current through it in different directions. As that's happening, you're able to induce, well actually you're passing the current through it, as you're passing the current through it from piece to piece, you're changing the direction of the current that's flowing through this, or you're switching it off and on again, and that's allowing you to spin this around, which is quite neat. Sometimes you can glue this little, or like stick with putty, this little magnet in place somewhere and leave it running for a really long amount of time. But you can explain this here if you want to have a go. If you aren't able to do this, we'd still like you to have a go at explaining how this was able to happen in the video. Now that brings us to the end of Lesson 3. Lesson 4 is entirely about reviewing the content, which we will do when we do our Google Meet. This is a summary of the SciPad pages that you need to complete for this week. And here's a little note on the revision we would like you to do in preparation for your test next week. But that brings us to the end of our content for today. So we had some content there around around magnetism in general and around electromagnetism, and one example of a practical activity that you could do. Just a reminder that next week we will be preparing for our end of term test, which we will sit between Wednesday and Sunday. If you know that Education Perfect's an issue, or accessing it or doing it in that way is an issue, get in touch with me, and then we can figure out a solution that will work for you. Okay? I can see everyone who's marked themselves as present, so by saying kia ora, so I will mark you all as present, and I'll hang around for another minute or two if you want to ask me any questions. But that brings us to the end of our content learning for this week. So look after yourselves, don't stress out too much. If you have any questions, you can leave them in the chat for me or bring them to our Google Meet later this week. Alright, have a very lovely rest of your day, team. Mā te wā.
Catch you later.